Alright, let's do another example using law of cosines and solving an oblique triangle. Now this example is a little different. This time we got all three sides given. Last problem was a side angle side example. So again, let's go ahead and get a quick picture of what this triangle would look like. Let's go ahead and draw in this triangle ABC here. So let's go ahead and label our angles A, B, and C. Now side A was given. So side opposite of angle A is 8 feet in length. Side B, the side opposite angle B, is 19 feet in length. And side C, the side opposite angle C, is 14 feet in length. So again, what type of triangle? Side, side, side triangle. And with side, side triangle, all three sides given, we're going to have to use a law of cosines in order to find these missing angles. We can't use law of sines, not yet at least, right? Because we've got three sides given. We would need at least an angle given, right, in order in this problem to talk about finding law of cosines. But we don't. So we remember side, angle, side, right? We can use law of cosines. Side, 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 law of cosines. Angle, angle, side, angle, side, angle, law of sines. So let's go ahead and look at finding these missing pieces. So again, we need to find three angle measurements. So we can find two of them with the law of cosines, right? We can go find the third one, right? Third one we can find using geometry. So just a little bit of trick to use, and that's our law of cosines. So let's start with angle A. So if I want to find angle A with law of cosines, we know that we'll need to pick side A. Right, so a squared equals b squared plus c squared minus 2bc times the cosine of angle A, right, with law of cosines. So as we plug that in, look at that. All right, what do we have? Side A is 8, so 8 squared equal b squared plus c squared. B is 19 plus c, which is 14, minus twice the product, 2 times 19 times 14 times the cosine of A. And now I've got to do a little bit of algebra. So I've got to solve for A, get that A term by itself. So let's go ahead and subtract. All right, move that over. So I got 8 squared minus 19 squared minus 14 squared. And then we'll go ahead and divide out the coefficients. So it'll be negative 2 times 19 times 14 equal to the cosine of A. And then, of course, we can use the inverse to get A. A is equal to cosine inverse of this fraction, 8 squared minus 19 squared minus 14 squared, divided by negative 2 times 19 times 14. And we'll go ahead and round it to a whole number, nearest degree. So let's go ahead and put that in our calculator. All right, and I'll let TI do the work for me. Alright, so let's go into our calculator and we'll type this in and see what we come up with, the angle measurement. So again, I got to get cosine inverse, second cosine key on our TI. And again, let's put it all in one step. So let's type in the numerator. Notice I'm putting parentheses around it. Make sure you group it. 8 squared minus 19 squared minus 14 squared, close it. Divided by my denominator, negative 2 times 19 times 14, close it. And then close that out. And what do we get for our angle measurement? Got 22 degrees, right? We go to the nearest whole number. So 22 degrees for angle A. So there's 1/3 of our known. So we've got angle A's measurement. So this angle, again, is 22 degrees. Now let's go find B, right? So what we're going to do to find angle B, I'll do B. B or C, doesn't matter. I'm going to go to B next. And with that, we're going to need what? Our law would be what? B squared equal A squared plus C squared minus twice the product, 2AC times the cosine angle opposite, which is B. So let's plug in information. So B is 19 feet. So 19 squared equal to A squared, 8 squared, plus C squared, 14 squared, minus twice their product, 2 times 18, or 8 times 14, and then what? Times the cosine of angle B, which is our unknown. Got to get B. we got to solve that. So we're going to have to isolate that term, do a little bit of algebra first. So we'll go ahead and do that in one step. We'll go ahead and subtract, right, the 8 squareds and divide out the coefficients. So 19 squared minus 8 squared minus 14 squared divided by the coefficients of cosine b, which is negative 2 times 8 times 14. All that's equal to cosine b. So we need b, so we're going to have to use inverses. Cosine inverse of this fraction, right? 19 squared minus 8 squared minus 14 squared, right? All divided by negative 2 times 8 times 14. And again, we'll go nearest whole number. So let's go put that in our TI. Let's see what we come up with for our angle measurement. So again, second cosine. And again, parentheses. Let's put in the numerator 19 squared minus 8 squared minus 14 squared. Close it. Divided by denominator. Let's group it. Parentheses. Negative 2 times 8 times 14. Close it. Close out that parentheses. And I got 116.8, right, which is 117 degrees, right? So 117 degrees for the nearest whole number would be this angle, which is what? Angle B. So now we've got 2 of the 3 angles. So what will angle C be? So let's find C. So to find C, we know C is equal to, again, 180. Use some geometry. We know all 3 angles must add to 180. So 22 degrees for angle A, 117 degrees for angle B. So we've got 180 minus, as we add those up, what do we get? We add 22 to 117, get 139 degrees, and 180 minus 139 is 41 degrees. So there's angle C, right? 41 degrees would be angle C. So we got all 3 angles. So again, our triangle has been solved. So again, we can label our triangle up here. 22 degrees for A, B is 117 degrees, and angle C is 41 degrees. All right? So again, that's solving a oblique triangle without a 90-degree angle in it. So we need our law of cosines, right? Or our law of sines when we're solving oblique. And these 2 examples we just finished with are 2 types we're using law of cosines with. And I stuck with the law throughout. Just wanted to show you some good review with it.